these slides available?
Yes, so the slides are all, that cat, this is going to drive me crazy. It's much more interesting than anything else we could show here. So if you go to github.com/neurohackweek/Python tips and tricks, and eventually I think all of the well, I wouldn't say all, most of them will be up here. So just find the what you're looking for. And it's an IPython notebook, so I guess one downside, actually I don't know if Fernando would have presented the IPython notebook. I'm not going to have time, especially given the delay, to talk about the Jupyter notebook. Does everyone, well, how many people have used the Jupyter notebook before and are comfortable with it? Okay, good. So most of you will have, I think actually possibly all of you, should be able to, since it's a single file, you can just download it. You don't have to clone the repo and then just fire up a Jupyter notebook and you can follow along. Or if you don't want to do that, just it'll render online so you can just follow along here. I will say right now that I think I mentioned this in the morning, that the goal here is not, like, there won't be time to stop and have everyone go along with the code samples, etc. The really idea of this is to assume that you already have sort of basic programming knowledge, and this is more to give you like an idea of what things are out there that you might not sort of be aware of, and the next time you're in a situation where they're relevant, you'll think, oh wait, there's something that does this. I don't understand why this isn't. Okay, well, I'll ignore that and then hopefully it'll go away. Okay, so Python, as we've already tried to make the case, is a powerful language, right? You can do a lot of stuff in Python. There's lots of reasons why you might want to use Python, although there's many other languages you could use as well. One thing that's particularly nice about Python is it provides support for many different programming paradigms, meaning it's probably most intuitive if you're coming at it from an object-oriented perspective. But if you're used to doing functional programming, then Python will give you some functional programming tools. And so you don't necessarily have to sort of commit yourself to any one way of programming. Python is really unusually flexible in that respect. This is, I think, another very salient point, and I'll come back to this later. Python has an incredible standard library, meaning when you install Python, you don't have to go out and you still have to go out and install packages like NumPy, Pandas, etc. to do scientific computing. But out of the box, without any additional dependencies, you get all kinds of functionality that in many other languages you would have to kind of run off and find some other package for. And one of the things that this means, of course, is because people have done a lot of work creating really good modules, many of which are already bundled with the standard library, there is really no need to reinvent the wheel. And generally speaking, it's not a good idea to reinvent the wheel, especially when you have really, really wheelie wheels already made for you, right? So you can think of like the Python standard library modules as being like a nice, shiny, very round wheel. And that's what you get when you import some library. And most of the time, not always, most of the time, if you decide to re-implement something yourself, you're going to end up with something like this, and you'll have a bad time, right? Because let's face it, most of us are not spending a lot of time optimizing some particular web scraping thing, let's say in C, so that's really fast, and someone else has probably already done a better job. So a lot of what I'll talk about is really just learning how not to reinvent the wheel, which is really important. And this is really the kind of point I want to make, that there are many, many ways to be a good or at least a competent programmer. You can be algorithmically brilliant. There might be one or two people here who, when they were 10 years old, were already taking apart the games they were playing, and that's great for you. That's one way. Certainly was not my route to competence. You could just spend a lot of time programming. That I think is the most common approach. But one of the shortcuts to being competent is really just to learn the language really well. And it turns out in most languages, certainly in Python, one boring import statement can save you hours and hours of being really brilliant, right? You can spend a lot of time re-implementing this or implementing a really clever way to do something, and someone who knows the language might come along and say like, well, you know what, you could just imported, regular expressions. Why bother with all that work, right? So you can actually, do what you need to efficiently without necessarily being very algorithmically creative, but just knowing sort of what's available in that language you're using. So just to give you one example, and I'll come back to this, how many people are familiar with regular expressions? Okay, so almost everyone. Chris, you're not sure if you're familiar? Yeah, so either everyone or almost everyone. But many people, when they first learn to program, this is kind of, I think, similar to the example Ariel gave of his own, right? So when I was learning, I was spending a lot of time doing stuff with strings, and at some point, like a grad student in the lab pointed out that, there's this thing called regular expressions, and I was like, oh, wow, is that really, So I was hoping that there were people who weren't familiar with them, because then I could feel good about my being here. It's like, I've improved one person's life just by telling you about these things. So if I tell you, like, here's the task, you need to find all occurrences of the 3 uppercase letters immediately following subject, but only if they're not followed by additional numbers, right? Maybe someone had some really crazy data generation scheme, and this was what they ended up with. And that's your task, right? So this might be like a realistic thing you might have to do. And, you have your 2 options are to either be a master of string parsing or just know a little bit of regular expressions, right? So here's what the solution might look like. And again, I'll show you the code. You can run it on your own, but I'm not going to walk through every line of code, just to show you that this is, it took me a few minutes, but this is just a random string I made up. Let's say what you want is to extract here, let's see, over here, something like this, right? So this would be a valid example, 3 uppercase letters followed by 3 numbers, only 3 numbers, but this would not because you have more than 3 numbers, right? So here's one string-based solution. This is without importing anything from the standard library, just sort of pure sort of core Python. And there's many other ways to do it. Here's one. This works. So if I run this, I can assure you that you get the correct result, but it's correct given this input. I'm actually cheating. I'm using rules that are not given in the definition I gave. They're just I kind of noticed, oh well, you can split on the colon and shorten things that way. And even so, this is like 10 lines of code and some really horrific conditional statements. So that you could do it that way, or if you know regular expressions, you just write this and achieve exactly the same thing. So what does this mean for people who haven't seen these before? This is a regular expression, which is really just a compact way of expressing some rules for matching patterns in text. So this says basically take exactly 3, or find exactly 3 uppercase letters followed by exactly 3 numbers. Notice that we're putting these in parentheses, which means we want to capture that. That's something we want to save. We match anything other than a number 0 or more. And so that's basically going to say what that works out to is if you see a number after those 3, then it's not a match anymore. And so this works just as well. It's actually much easier to write. It's much more cognitively efficient to write this than to think about something like this. And it generalizes better because it presumably follows the rules you actually want. So it's a nice example of knowing regular expressions can save you a lot of headaches. And they are very powerful things that apply more widely than you might think. Although, at the other extreme, you can also spend a lot of time writing very complex regular expression. There's also a time and place for saying, you know what, maybe string split will do the job, and then I'll run the regex on like a split string. You don't have to always be as clever as possible. And so this brings me to the language learning catch-22. And the language learning catch-22 is this. You often don't know there's a better way to do something until you already know the better way to do something, right? Like if you know about regular expressions, then great, you know how to solve the problem. But if you don't, like how would you find out, right? It doesn't necessarily occur to you like, go and find a much better way to figure out how to process strings, right? Maybe that's not a good example, because if you Google string parse, you will get regular expressions probably right away. But for example, one of the things I'll talk about here is something called a decorator in Python. And I don't think many people sort of are coding and they run into a situation where they think, you know what really would solve my problem here is I need something that kind of decorates functions. That's what I need. It's sort of I can wrap a function and do some stuff before and some stuff after. I'm sure there's something exactly like that, right? That generally doesn't occur. And it's only when you see it that you think, oh, yeah, I can see how that would apply. So the goal here really is to kind of do that, hopefully, for people, where you don't necessarily have to understand the full example. You can work through the code later. But just to kind of have in your back of your head, like, oh, yeah, that's this kind of situation. I know there's a solution for this type of thing, or a way to do it more efficiently. Does that make sense? Any questions? Anything? Okay. So what helps? I mean, how do you learn about these kinds of things like decorators? Well, you can write a lot of code, right? That's the hard way. Reading other people's code is also very helpful. I recommend actually just, like this is what you do when you're bored and it's like for a good time, right? Is you go to GitHub and you find someone's code and just read. I mean, it's not often fun, but it's actually very helpful because you run into all kinds of constructs other people use that you've never seen before, and then you realize what they do and you're like, oh, that's really actually kind of a powerful way to do it. You can, of course, read programming books, blogs, etc., or you can be forced to sit through someone, forcing their own tips and tricks. And so that's what I hope to do here. Okay, so without further ado, the game plan is this. In the not that much time we have, I'll kind of build up. I'll start with very basic tips that probably everyone who uses Python has seen before. List comprehensions, probably most of you have seen before, if not all. And gradually build up to more complex examples that for some people will probably be a little more difficult. Like if you haven't done much object-oriented programming, some of the stuff at the end will probably lose you. But that's okay. At least you'll know that here's the kind of thing I could do if I sort of spend some time learning to use these kinds of tools. And many of these tips are sort of individually small, like list comprehensions. They don't buy you a lot of time versus writing a for loop, but if you think about it compounding, right, like a script where you might have 20 of these things, the savings can really amount to, in the long run, there can be pretty big savings. And they compound too, so if you stack a lot of these little things and these Python idioms, you can often save yourself a lot of time, so it's worth knowing them. Now, brevity and power do come at the cost of clarity, right? And I will show you some examples where I will say, like, you could do it this way, but don't, because it's going to make it very hard to read your code. So you always want to kind of be aware that just because you can do something in a very compact way doesn't mean you should. And when in doubt, I would say err on the side of clarity, at least if you expect anyone else to read your code. If it's just for you and you know for sure you're the only person who's going to read it, do whatever you want. But if you want other people to actually use your code, ideally build on it, then sometimes for loops are better than a really complicated list comprehension, which I'll show you in a moment. Okay, so I'm just going to walk through, and again, there's no sort of overall coherent narrative here. It's just a bunch of tricks in different areas, and there's lots of stuff that I could have talked about and didn't. So people should feel free. At the end, I'll sort of ask you guys to contribute some other things that you might want to throw in. Okay, so string tricks, formatting strings is something we do very often. The most obvious when you first start a program way to format a string is something like this. So here you have my name, date of birth. Good luck with that social security number. You're welcome to go in and try and open a credit card with it if you want. But let's say I want to print a string that says roughly something like, my name is Tal Yarkoni, my date of birth is blah, 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 my social security number is, and I have, X fingers and toes. This is a very naive way to do it, right? So just literally concatenate these things with the plus operator, which for strings says just append to the string. So all we're doing here is just taking a bunch of strings, and in between we're adding the variables. And notice that when we have numeric variables, we need to wrap them in this string call to turn them into strings. But that's simple enough. So you can do it this way. There's nothing wrong with this. It works. And if I run that, here's what you get. Right, great. But it's not so efficient, and it's also hard to read. I mean, this is not really so clear. An alternative approach to formatting, this is now what's called old-style formatting. Python actually has a couple of different ways you can format strings. Is something like this. So here you can think of this string as a template. So I'm first writing out the string without any of the variables, and you can see that I have these weird things here, and they're placeholders for variables that will come later. So what I'm saying is, here's a string, and I'm just making a note that I'm going to inject some variables into this, and so and you'll see that what this here means. What is the name of this thing, by the way? Like, it's a percent thing. Is there a name for this character? Does anybody know? Just percent. Is there not, like, okay, there's no more technical name for it? Okay, so that basically says that's a placeholder for a variable, and then there's different types. So Python has its own little formatting language, and so this is basically says whatever variable gets passed in should be treated as a string, whereas this is an integer. And over here we're saying please format this as a float to 2 significant digits. Okay, and now you'll notice that we're passing in a tuple, which hopefully you're familiar with tuples in Python, and notice that these get injected serially, right? So the first one they'll get mapped on 1-to-1 basically. So name will go here, date of birth will go here, etc. And so if I run this now, here's what you get. And notice that I have 20.00 fingers and toes, like very precise about the number of fingers and toes I have for free. I didn't have to do any magic to the number itself. I just formatted that way. Right? And so this is also nice because you can maintain the same representation of your object in the code, and then when you output it, you can make it look like whatever you want without having to actually manipulate the data, which is generally a bad thing. Right? Generally, you try to avoid manipulating underlying data if possible. So that's old-style formatting. It works fine. You can go and read up. There's lots more power to it than what I'm showing you here. There's also new-style formatting, which I personally actually don't like as much, but I guess in theory is the way, it's the recommended way to format now. Oh, let me just, before I do that, show you that one really useful thing about this kind of thing is it allows you to build templates, right? So you can think of this, imagine like writing reports. So you run some code, and you know that you have like a fixed template that you're going to want to inject the results of your code into, but the template is already there. And so you could have, for example, like an HTML string that just sits there, and it's going to render HTML, and all it's waiting for is the results, the data that's going to get plugged in. And so that's sitting there, and at some point, could be weeks later, when you run some code, you can then take that template and inject into it some variables, in this case a bunch of strings. And so when you run that, this code is just to display HTML in the Jupyter Notebook. Here's what you get out. So you can build templates for reporting very easily with this kind of thing. Okay, new style formatting, which I already mentioned. A little bit different. You have these curly braces. And same kind of idea, right? So when you give it arguments here, they'll just get mapped one-to-one. But notice you can also do some other things that are kind of neat. So you can actually name variables, and they can be out of order. So here I can say, the blank blank animal 1, and so that's saying that if I pass in a series of arguments like this, and there's a variable named animal 1, it goes here. It doesn't matter where in that list it shows up. It's going to get plugged in there, right? So I'm naming the thing, and so on animal 2. And again, you can also format these arguments. And so if I don't name it explicitly, then it goes serially. And so when I run this should be familiar. And what's happening, so the thing about what's happening is it encounters this, and it says, well, okay, first of all, it figures out where the named ones are. So, animal, okay, we know animal has to go in there. We know that animal 2 goes in there. And so of the remaining ones that are unassigned, it then goes serially. And so you can combine these things very flexibly to create your output string. I'm not necessarily saying you should do it this way, and ideally kind of be consistent about whether you name your variables or not, but you can do interesting things. And notice that this float, again, is getting formatted to 2 significant digits, right? So they're a very powerful way to format strings. Regular expressions I already mentioned, and since I think people are familiar with them, I won't belabor the point. You import regular expressions in Python from the RE module, but it's standard library. You don't have to install anything. Let's say you have the sentence marking the lives. 4 out of 5 doctors recommend using regular expressions at least 3 times a day. And I want to pull out all the digits. So that's a very simple regular expression. Just capture the numbers. Or maybe I want all the words between 5 and 8 characters in length. And you can spend a whole lifetime learning about regular expressions and all the different kind of functionality they provide. These are very simple examples. It's a little more complicated. This is a very crude and actually not entirely accurate email validator. And just to show you what that looks like, here are some email addresses, some of which are valid, some which aren't. And if we then take each one of these and run it through, you can see whether it matches the regular expression or not. So, this is not valid, these are valid, this is not valid, you can't have, a non-alphanumeric character at the end of an email address. So you can do very, very powerful things with regexes. Okay, iterable tricks. List comprehensions are one of the first things people learn. This is always like the thing people say, like, look at what you can do in Python, even though you can do very similar things in many other languages, right? Like, it's like Python people not realizing that you can do similar things in R and many other languages. So let's say you have a list of subjects, 1 through 10. So I could write this, let's say I want to do something with each of those elements. I could write a for loop, right? Everyone should be familiar with for loops. Or you can write a list comprehension, which is just another way of expressing a for loop. And it basically says, do this thing for every element in there. So this is, you can see the for loop right here, right? For every S in subject, do this thing. And so, but it's nice because you're just wrapping it all in one list. And so you can put it on one line. So here we're just adding 100 to each of those values. And if I run that, out it comes. This is equivalent to this. This is the explicit for loop version. You would have to first, one thing you have to do is have to first assign some result, some placeholder. So you have to allocate memory for this result explicitly. And then you loop over the subjects and you append to this thing, and then you can reassign it. So you can see that you save like 3 lines of code just doing this. And it's fairly readable. Right? So there's no reason not to use list comprehensions like this, I would say. They're actually arguably more readable than this. So that's nice. And you see these all over the place in Python. You should get comfortable using them because in the long run, they will save you a lot of time and improve clarity. You can also embed conditionals into list comprehension. So in this case, what we're saying is, so let me just show you that this works. If I run it, get the same result. Here, what I'm doing is, The same sort of thing, I'm saying do S for every S in subject, which means we're not touching it, right? We're just passing it right through. So for every S in subjects, just give S, but only if S is greater than 105, the value is greater than 105. And so it's a really nice way to filter very quickly. So if I run this, now you only get some of that list. And so it's a very quick and, again, compact and readable way to do conditional filtering. Now, you don't have to stop at one level. You can also do nesting of list comprehensions. For example, let's say I have these two lists, fruit and animals. Here's a nested for loop, or nested list comprehension. And so this now is starting to get more complicated, but just think of this as two levels of, for every F in fruit, that's the first level, and then within that there's an inner loop that says for every A in animals, and same idea, now you can do whatever you want with those variables. So that works fine. If you run this now, here's what you get, right? So you have, it's 3 by 3, so you're going to have 9 elements. This works nicely. I would generally recommend not using nested list comprehensions unless they're like this short. If you're doing something like this, fine, it's easy to read. But you will see people doing like horrific things that take you like 5 minutes to understand, and it's just not worth the, yes, you can show people how clever you are by having like a three-level list comprehension, but it's generally good to avoid them, I would say. Yeah, Ashton.
I was going to say, like, you use one common pattern I've seen a lot, and I've used a lot, is if you're using a 2-level one like this, you can flatten out like lists in Python without having to turn to like NumPy flatten or something like that.
Yes. Yeah, so yeah, there's definitely use cases, and I'm not saying you shouldn't use them, but use them when it's kind of clear at a glance what's going on. And you could easily add a 3rd level here, and at some point it becomes fairly obtuse code. You can also do dictionary comprehensions, some people don't realize. I think these are newer in Python, but I think Python 2.7 and certainly 3 support them. So same kind of idea. You can iterate over the key and value pairs of a dictionary and do whatever you want with it within the dictionary comprehension. Notice in this case we're specifying that the result is going to be a dictionary. That's why you have these curly braces, which are how you initialize a dictionary. But the idea is the same. So here's a dictionary. Keys are A, B, C, D, and here are your values. And in this case, let's say we want to reverse the keys and values. So we want to make it so that now the dictionary keys are 1, 5, 7 orangutan, and the values are A, B, C, D. We can do that very nicely in a dictionary comprehension. The way to read this is for every key and value pair in my dictionary, right? Items is an iterator over pairs. It might help to, if you kind of are fairly new to Python, it might help if that might be clear as to what's going on. So for every tuple that comes out, we're now returning, you have to return a key and a value again. And so now we're making sure that the new key is a string. It doesn't have to be. I just wanted to show you could apply operations to the values here. And the value now is getting set as the key. And so now when you run this, right, 1-line reversal of the dictionary, which is kind of a handy trick. There's lots of other things you can do with dictionary comprehensions. Zip is a really useful built-in function in Python. And it took me a little while to understand what was going on until I realized the really simple way to think about what this does is it turns rows into columns and vice versa. So in a situation where you have, let's say, 2 lists like this, what zip is going to do, so here's the first element, second, third, first, second, third, is it's going to basically take the nth element of each of the lists that are piped in, or tuples, any iterable. And so what you're going to get is like the first tuple you get back is this now. It's apple and aardvark, banana, bonobo, cantaloupe, and cheetah. And there are many, many situations where this actually is really a very helpful thing. Right? So you run it, and that's what you get back. So you've essentially indexed these now kind of going this way instead of that way. Does that make sense to people? I won't go into like all the cases where this is helpful. If you work with NumPy at all, there are lots of cases where this helped you get really, really quick indexing of NumPy arrays instead of having to do all kinds of other things. And just to kind of show you that this works, of course, both ways. We could, of course, do exactly the same thing. This star operator, I'm cheating a little bit. I'll get to that, but you can see the result is the same. So you zip twice, you get back the original result, basically. Okay. All right. Okay, so those are some iterable tricks. Assignment. As you know, you can do things like A equals 3 in Python and virtually every language. But you can also do multiple assignment, which is handy. Although again, this is one of the things you can abuse. So if you don't like assign 8 arguments on the same on variables in the same line, that can be confusing to read. But sometimes it's actually clearer if you have something like this, where you can say A, B, and C all in one shot. Particularly helpful when you're assigning the same type of variable, right? They're very similar. Then it's very clear to the reader, like, okay, these are sort of the same thing is going on in all these cases. So if I run this, we've assigned them. You can also use swap variables. This is a little less intuitive, but the thing about Python, and I think most languages, is that you have to remember that whatever happens over here happens here first, and then it gets assigned to the left side. And so you can actually flip variables like this in one shot. You don't have to have a third dummy variable. You have to do like A equals C, now B equals A, and now B equals C, or whatever. You can just flip variables if you want to for some reason in one shot. Okay. Now a really cool thing, well actually this is a little bit cool, and the next thing is really cool, is you can unpack iterables. So if you have a list like this, PFC, IF, GSTS, right, so we're just assigning, that's like the variable. You can now assign in one shot to multiple variables as long as the number of elements matches. If it doesn't match, you're going to have problems. So if I did, if I did something like this, then it's going to complain. The number of variables on the left side have to match the number of elements in the iterable on the right side. But this is also a very handy thing, because where you often see this used is if you get like a tuple back for some function, and you don't want to have to like say, okay, the first element is this variable, the second one is, you can assign all the names in right away. Right? So I find this incredibly helpful, because you have like a 5-element tuple coming back from a function, and you can automatically say, okay, the first one I know is the name, the second one is going to be the date, etc. And then you don't have to waste 5 lines of code writing out something fairly boring. Now this is kind of neat. It only works in Python 3, unfortunately, which is another good reason to if you're not using Python 3, you should, because there's all kinds of cool stuff in Python 3. So this I really like, right? So you have now 5 elements, and the problem that often can be run into when you're coding is you might want only the first element and the last. You don't really care about the rest. So you could, let's say I wanted to do that, right? You could write something like this. You could say like, well, the first is region 0, and the last is regions -1. Another helpful trick, by the way, you can index from the end, right? So you could do that. But maybe you want to keep around the middle for some reason, and you want to remove the first and last, and then it becomes more complicated. Well, this star operator in some languages called the splat, I don't think it has a name in Python, will actually, you can think of it as like whatever's not otherwise accounted for, right? So if I do this now, what's happening is that Python knows that the first variable has to grab the first element, and the one at the end presumably has to grab the one, but everything in between is unaccounted for, so it just dumps it in here. And so now you have this. So now rest now has everything in between. And this is a pretty powerful thing, and it has some other uses. Okay. What happened here? Oh, right, so I guess we're still talking about assignment. Okay, so unrelated to the previous example, another thing you can do when assigning variables is conditional assignment. So for those of you coming from R, this will be familiar. Many languages have a similar construct, right? So it's kind of annoying to always sort of write out the if X, then A equals 2, else A equals whatever. You can do that all in one line. So here's a little class, a shape class. And when you initialize it, you specify how many sides the shape has. And so let's say you want to, it has a method count that tells you how many shapes the side has. And what we want this to do is basically return the number of sides if there's fewer than 20, but it's not too good at counting. So if there's more than 20 sides, then it just tells you that, I'm sorry, you can't count that high. I don't know what's going on with the display here. So what we're doing here, well, here, another Python trick with like you can break up long lines with the backslash there. So what we're saying when this count method is called, what happens is that we print the value that's actually stored in shape.size if that value is less than or equal to 20. Otherwise, we do this. right? And so I guess this isn't really assignment, just to make it clear what's going on here, you could do this, right? So basically, the value of this is dependent on the outcome of this conditional here. And again, this would be is exactly equivalent to writing out on like 4 lines: if shape size less than equals 20, then A equals shapes dot size, else A equals, right? Again, another thing that you can abuse if you're not careful with. So my rule of thumb is like if you go over 80 characters in the line, then don't do it because it can get tricky to read. So if you run this, it says invalid syntax, probably because this is actually.
I think it's because the close bracket at the end.
Oh, what happened?
From your previous.
Oh, right, because yeah. Okay, there we go. There we go. So it doesn't, that's the. All right, function tricks that have to do with functions or methods. Lambda functions. How many people are familiar with lambda functions? Okay, you guys are like, I can skip through this apparently because you shouldn't be here. Like you should be like learning about GitHub or something. There's just anonymous one-line methods that save us some typing. They're like anonymous functions. Well, more or less like anonymous functions in JavaScript. In JavaScript, you can have lambdas that aren't anonymous, but in Python, this is what you get. So here's your data. And let's say you want to filter these tuples. You only want to keep the ones that sum to more than 5. So you could write a new method that's like def sum args, takes the tuple, et cetera, and then it does an if statement. But that's like a lot of writing for no good reason. And you're not going to keep that method around. You only need it that one time. And so you can just express it with a simple lambda. And a lambda is just a function that disappears. You can't refer to it later. And you can give it arbitrary arguments. In this case, we say this lambda expression expects a variable x. You can do whatever you want with it. And it will return either true or false. And filter is a built-in Python function that will only keep the values that are true, and so this very simple thing lets you filter very efficiently. And it's equivalent, that lambda is equivalent to this, right? So it's, they're equivalent. And only one line code blocks can be lambdas. You can't start like having multi-line things in here. Okay, so yeah, there you go. It's equivalent to that, just to show you. Okay. Just like conditional assignment, you can do conditional function calls. This slide includes possibly the worst joke you will hear this week, but you have to be in your like mid-30s, let's say, to get it. But don't try because you'll probably groan and walk out of here. So you have these two methods. Which one should you call? Well, it depends on the value of this variable here, and so you can call this one, right? So you don't have to assign anything. You can just embed a function call that's dependent on the conditional. Okay, this is cool. So the fact that you have this like packing and unpacking syntax, where you see already the star operator, lets you do some really interesting things in the context of functions. So here's a function. It's a little more code. We'll work through it line by line. How much time do I have? Not much. So ignore everything down here at the bottom. Imagine that we just had this thing, right? So what would that do? What does this amazing function do? What does it return? Just the sum of A and B, right? That's all. Okay, so nothing confusing about that. You can ignore these extra things. All right. What does this star args do? Well, it handles variable positional arguments. What does that mean? That means that when I call this, I can now do something like, in fact, let me show you. So if I did this, what's gonna happen if I do this? Nothing good, right? I run this, I'm passing in 3 arguments, but the function expects 2, and does not like that. It takes 2 positional arguments, but 3 were given. But when I add this star args thing, which can be called whatever you want, it doesn't have to be called args, but that's just the convention. That's basically saying like, handle as many arguments as get passed in. Could pass in 15 variables if you want. So if I run this, it will not complain at all. It's not returning anything because I didn't tell it to, but it works fine. It's perfectly valid code. And the reason is because this args variable is now capturing every other variable you give it as a list. So if I had 8 arguments here, the first 2 would get mapped onto A and B, and then the other 6 would be sitting inside args. And so I could do something like this now inside this code. I could say for every A in that argument list, add that to the total. And so now what's the result going to be of this? Somebody can do mental arithmetic here, right? 12, I think that's right. Well, I guess we'd have to print it, but it's 12. I can take my word for it. Okay. I'm too lazy to actually type print. Okay, and so that's cool. These arguments are not named, so they would have to be passed in like this, just as values. But let's say I want to get more creative. I think, I can add another argument that's animal equals orangutan, and I try to run this, and does not like that because it's not expecting keyword arguments. Nowhere have I told in the signature here to expect named keywords. It's just expecting a variable number of arguments. And that's where this KWArgs thing, again, just by convention, stands for keyword arguments. That's now capturing named arguments as a dictionary. And so now inside the function, I'm going to have a dictionary that contains everything that was passed in like this by name that's not otherwise accounted for. So if I did, it's still the case that if I did, A equals, oops, A equals 5, that one would because A is not named. But I could do something like this, and that'll be fine. So I am allowed to call these by name if they have a name, but if they don't, now these will get sucked into this keyword argument dictionary. And now that's really powerful because that means that I can handle arbitrary variables that get thrown into that function and not necessarily spit out an error, and not even have to know exactly what's coming, right? So you can write a function that can handle variable arguments. Like it can be set up to think, if I get this argument, I do this thing. If I get this one, I do this, and you can check inside. And so what we're doing here is we're saying, look, if someone passes an argument named add, then we'll add that to the total. Otherwise, get is a dictionary method that just allows you to specify default. So basically, the total, what we're adding to total is the value in add if it exists, otherwise 0. That's the way to think of that. And so now, if I run this, what'll happen is, let's uncomment this and finally we'll actually see. So if I run this, what'll happen is, sorry, I need to change this. So still 7, and that's because it's not animal gets dumped into keyword arguments, but we don't do anything with it. It's only checking for add. But now if I change this to, let's say, add equals 7, and then I can have a bunch of other arguments here. Right, so now it's going to actually add that. Okay. Does that make sense? Hopefully, okay. So this is a very, very powerful kind of abstraction. Lets you write methods that are very flexible. You can abuse this too, right? Because what you don't want to do is write methods that inside are checking for like 50 different variables when the user from the outside has no idea what right. So it's a good practice generally, if there's a fairly small number of arguments, to always put them explicitly in the signature. But there are definitely also cases, for example, a common one is when you want to take this keyword argument and pass it on to another method that you call. It's a very common pattern that you don't even have to care, right? So maybe my code is going to call some plotting thing, and it takes in keyword arguments, and then it just passes them right back out. And so it's very powerful because it lets the user, you write some code that does something and then calls something else, and the user still gets to specify what this other code you're going to call does. So you'll see this pattern in a lot of places. Yeah.
When you're passing it on, do you use the stars?
Yes, exactly. Yeah, that's a good point. So yeah, so what you would do inside the function is you would do something like, let's say you're calling Seaborn, you would say, like that. And so think of the stars as being unpacking. So what it's doing is it's actually, as it's calling that, it's splitting those keyword arguments, and from the receiving function's position, it will look like this. So basically, in between your calling of that function and the receiver, it's actually being unpacked into arguments. Or you can think about it the other way, that everything is always coming in as actually a dictionary of arguments.
So the signature is packing anywhere else it's unpacking?
Yes. Well, it's you can think of it as like an invariable operation, right? So it's basically saying there's like more than one thing coming your way. Okay. All right. Partial functions. These, I think, fall into the class of things that like you will probably never need, but you may need them a lot, and then they're really, really helpful to have. So a partial function allows you to create a function that pre-fills some of the arguments of another function, right? So Let's say you have this code here, and this lives inside the func tools. So Python provides you some, not a lot, but some tools for doing functional programming. So let's say you have this character function, and it just returns a string. So you give it a name, a trait, and what this character likes, and it gives you a string like, so-and-so is whatever, and they enjoy this thing. So just to show you how this works, let's say you have a lazy person named Joe who likes ice cream. Great, like totally trivial example. Right. But let's say that now you're working in a context where you don't actually need, for some chunk of your code, this trait thing is irrelevant. You know that all the traits are going to be set to the same value. And so what you can do is you can create a partial function called conniver, right? So look, for the foreseeable future, all of the characters are going to be conniving. I don't need to keep setting trait equals conniving. And so you call a partial function, you give it this function as the first argument, and then you can give it whatever arguments you want. Again, it's using this keyword arguments thing, so you could pass along whatever you want here. And so what this is doing now is it's basically creating a new function that's a partial function of character with the value for trait already set to conniving. And you can call that function. So now when I then code to call this, so now later on I can call conniver with the argument Sue, and Sue likes suffering. And if we run this, then you get that. And notice that normally, if you tried to call character with this signature, it would complain because it's expecting 3 arguments. You give only 2, right? So partial functions, again, you probably won't never need them, but there are contexts where you need them all the time, and they're super useful because you can sort of in advance create a thing that responds the right way that's contextualized. Any questions about these? Okay.
And you could do this in just totally stock Python with the definition. It just saves you velocity, right? The function just calls another function with one argument pre-filled and then unpacks arguments from the calling environment, right?
Yes.
Okay.
Well, I mean, sure.
You do a lot of clever packing.
Yeah, I mean, you might need you might need to have a class that maintains state, so you know what arguments are right. So,
yeah. But
you could do it very simply here. Okay. All right. So now I'm coming to the standard library. All the stuff I showed you, except for the partial, is sort of core Python. But the standard library, which you have to explicitly import from and actually gets regular expression too, contains all kinds of good stuff. It's really worth just browsing the list of modules, because there's a lot of stuff that I would not have expected to be implemented out of the box. So you expect math, but there's iterator tools. There's pickling, so you can serialize. You can read. So one thing that you may not realize you can do is you can read compressed files without decompressing them first. They're decompressed on the fly, so you can actually read gzipped files without having to worry about how the hell should I. You don't have to first unzip them and etc. You can read them directly, and Python will handle all the hard work for you. So there's tons of stuff that you just look through and realize you can do all kinds of things that you might not have otherwise known. I'm running out of time and I haven't gotten to all the cool stuff, so let me speed up here. These are some of the modules that do some of the more helpful ones, I think. Collections I will breeze over because there's tons and tons of documentation about this stuff. The collections module contains useful container data types, so they're things like lists or dictionaries that just add a little bit more functionality. And the nice thing is they're very efficiently implemented, so often there's no real downside to using them. They're more flexible, you don't lose much, so you may as well use them. Default dictionaries are basically dictionaries that give you a default value. This is a normal dictionary, so if I create a dictionary called tree counts, I'm just counting the number of occurrences of each value here. Notice that I have to do this. Every time I'm looping through this, for every element I have to check if there's already a key for oak in this case defined in the dictionary, and if not, then I initialize it to a value of 0. If I don't do that, it'll raise an exception. You can't assign something to a value that doesn't exist in a standard dictionary. So that's the expected answer. A default dict basically just lets you specify a default type that initializes to whatever the object's default value is. So if I say default dict of int, then when I do this now, I'm looping over the same list. When it encounters a t that doesn't have a key for, it just initializes to an integer. And so this lets you do things like this where you don't have to have this annoying conditional check. So in a case where you're going to be doing this a lot, it's I think useful to import default dict because you don't have to add a couple lines of code here and there just to check whether the value already exists. This works just fine. The other one that's super common, or the second one, is ordered dictionaries. Just like the name says, dictionary that remembers the order of insertion, which means that in an ordered dictionary, if I create an empty dictionary and then assign this as the first key, this is the second and third, it will remember the order. In a normal dictionary, that's not the case. So just to illustrate, the order dictionary, if you call the keys, you notice they're always in the same order that you entered them. In a normal dictionary, there's no guarantee, and you can see here, first, third, second, right? There's no concept of order. Again, no real downside to using ordered dict. So if you want, you can always just use an ordered dict everywhere you use a normal dictionary. There might be some tiny memory cost, but nothing meaningful, unless you're creating like 1 million dictionaries. And there are all sorts of situations where it's really helpful to get the order in which you entered things into the dictionary. And last thing is named tuples, which are just tuples that have named attributes. So it's a little more complicated. Named tuple is really sort of you can think of it as a factory for a class. Here we're creating it's really a class called study, and what you're saying is this is an object called study, and it has the following fields: name, authors, and status. Thereafter, when you create a new study like this, it's basically a tuple, but you can refer to it by name. So normally tuples you would have to request to the index, but here you can do things like this. So, and just to show you that this is indeed, just in case you don't believe me, right? So here's your tuple. You can see the parentheses behaves exactly like a tuple, but you can also refer to it by the name of the attribute, which is super useful in many cases. Okay, all right, now we come to some of the coolest stuff, although well, nobody's kicked me off yet, so I'm just going to keep going until someone shows up. And
then try and start the next one by 2:05.
Okay.
We were trying to get to.
We'll just, who's after?
Jeremy.
Okay, well, I'll just ignore him until I'm forcibly removed. Okay, so one thing you can do, and now we're moving into object-oriented programming. So let's say you have this class, an image class that does absolutely nothing. Well, ordinarily in any class, unless you explicitly restrict it, you can assign any attribute you want. So I can initialize this new image that does nothing, and I could say, well, image has the shape attribute, and you can see that if I then print that thing I just set, in fact, it is set. Okay, well, that's great. But notice I had to know what the name of the attribute was in order to do that, right? Another thing I could do is I could do this dynamically. So I could use the set attribute, which stands for set attribute, and get attribute methods. And now what I'm saying is I want to set on this object image for the attribute shape. I want to set this value. And the same thing on the other end, right? I can get the attribute out of image that's called shape. And it behaves exactly the same as what I just showed you. Okay, so you might look at this and say, well, like, what the hell is, like, why? Right? There's just more typing. And the answer is because you sometimes don't know what attribute you want ahead of time, right? So there's no way to call, like, if you don't know ahead of time that you're going to want the shape of that thing, right? Someone could say, well, I want, I don't know, the dimension, the number of dimensions or something. How would you do that? And so here's an example where this might be useful. Let's say you have a person class. When you initialize the person, you have to specify the brand of their shoes, shirt, and hat, and it stores those internally. But now, this gives someone the flexibility of asking at some later time, like, what item of clothing they want to know the brand of. So they don't, they might store as a string somewhere the name of that thing. And so just to show you what. And so now let's say that I create this person named Bob, who's wearing Teva shoes, a Hermes shirt, and a Dunlop hat. Probably nobody has ever worn that combination before, but it could happen. And so now you can do things like, of course you could always do, so if we do this, you can always do Bob shoes, right? But you might not know this at runtime. You might be waiting to receive some, maybe like someone is sending you some message over the internet that says it's the shoes that we want. And then you don't have to rewrite a new script. You just pass this into this get clothing item brand, and internally you can retrieve the right attribute. So this is actually super helpful in many, many cases. Again, it's the kind of thing where it might not jump out of you like all the cases in which it helps. Once you start writing a lot of code, there are cases where it's kind of unavoidable. All right, the last set of things I'll show you are some magic methods, which are kind of magic, right? So if you've ever wondered what the hell these double underscore things do, they just mark, like, this is a method you probably shouldn't touch unless you know what you're doing. Most common one is init, which you have to usually override. Just we'll explain by example. I think it's easiest to kind of get a sense of, I don't know what's going on with my display. It's not super helpful because you can't actually see the rest of the code. So let me just shrink this down. Okay, so here we have a little bit more elaborate example. We have a brain object that we set the owner, the age, and the status of the brain on when we first create an instance. And we're adding this repr magic method. And then we have a brain collection, which is a collection of brains. When we initialize it, we give it a bunch of brains we want to store internally. And we're adding a bunch of these magic methods, iter, get item, set item, and get attribute, which you've already seen. Okay. Well, rather than kind of explain, let me just show you what they do. So normally if you create a class, it doesn't really do much. It's just a container by default for a bunch of attributes. So if we initialize this class, here are our brains. We create 3 brains, and then we pass them into this collection. And now we can start to do some interesting things. So first thing we can do is we can do this construction for brain in collection, which is weird because normally if you create a new class, you can't iterate over it. You can't just say for x in this class I just created. We'll just complain that it doesn't know what to do with that. But what we did here is we created this iter. We overrode the magic method iter, which basically says you have to define it this way. Like basically you're looping over whatever you want internally, and it yields some object. And so when you call it from the outside, in every step, basically it will execute one of these iterations, yield b, you'll do whatever you want with it, and then once you're done, you'll go on to the next one. And so you can write your own classes that behave like a list or a tuple. And so we just added that functionality for essentially free. And the cool thing, notice about this is that we get to decide what we're actually iterating over. Like I've decided, well, what you really want to do when you iterate over the brain collection is iterate over the individual brains. Right? It could have said other things. We could have had other properties. Like we could have iterated over the owners of the brains if we wanted to. But no, we're saying that we want to iterate over the actual brains themselves, which we're storing internally in this brains dictionary. Okay, what else? Just to show you that this works, right? So you believe me. Right, so we're just printing each brain. Well, that's actually interesting. Like, how is it printing? Right? Like, why is it giving us this like nice string representation of the class? Where did the hell that come from? And the answer is we added that back here. This repr thing basically tells Python what to do when that object is called with no arguments. Right? If you just try to print that thing, what is it going to do? And it's going to return this thing. So we're basically defining a nice string that the user will view when they actually just say when they try to print that object. By default, you'll just see a pointer to the object in memory, essentially, which is not terribly informative. So you override that, now you have some interesting information. Another cool thing you can do, maybe we say, look, we want our collection to behave kind of like a list, or we want to be able to say, like, here's the value that we're setting in that collection. So we don't have to say collection, brains, append, whatever. We just want this thing. So we actually are assigning, almost like it's a dictionary, this new value, and we get that by adding this set item, right? So we override we don't override. We tell basically Python that this class handles this behavior. Whenever Python receives that syntax of trying to look something up by key, it checks to see if the class has this method. If it does, it calls it. If not, it complains. And so all we're saying here is when you get a key and a value, the key is the thing inside the braces, the value is whatever's after the equal sign, then we're assigning it, we're adding it just like we would any other value to the dictionary. And the inverse is also true, because the get item is the opposite, so that I could, although I don't have this an example, but I could have just, if I just printed, if I just print this, that, right, then I will be now accessing that element. Okay. Lastly, you can do this, you shouldn't do this, but this really is kind of magic, right? So you may ask yourself, where the hell did this actual method, right? Like, at no point did I create explicitly a method called getSue. Where's that coming from? It seems like a weird thing. And the answer is, and again, I emphasize this is not a good thing to do in general, although there are, again, use cases for it. It's this. So what happens when you try to access an attribute in a class, Python has like a series of things it'll do, and fairly early on is this. It will check to see if a get attribute method is defined, or sorry, it will, if it doesn't find an actual named attribute, right? So if it doesn't have, like if you were calling brains, it would just return brains. But if there is no key set, then it will call this method. And so now what we're saying inside this, we have the ability to essentially interpret that method name however that we want, right? So what we're saying here is like, look, if that method name starts with get, then we're going to assume that you're trying to get the brain by name. And so we're going to split that method name, take the second part, and call into that self brains thing and return that value. lets you do very powerful, alternatively horrific things, right? So you can literally take any name that you didn't know in advance, and you see, like, for example, there's like Rails, for those of you who've dabbled with Ruby at all. Rails does this all the time, right? You have these dynamic names. They're like find, so the method name is called like, book.find underscore by author, etc. And that's using this kind of approach, where it's dynamically figuring out, based on some expectations, what you're actually trying to do. If you're building domain-specific languages, this is a really, really powerful thing, because you can actually, as long as it's well documented, use this kind of thing in lots of helpful ways. But this is not even something you'd want to do like haphazardly. Like, this is generally not a good idea if you don't know, you could have like a million different things here and you just added like a getSue method everywhere. But it gives you a sense of the power of Python and what you can do dynamically. Okay, last thing, operator overloading. This really blew my mind when I first learned about it. I mean, this is, I think, really cool and underutilized, although there's different schools of thought about whether you should ever do this kind of thing. I think you should, but you want to be cautious. So you can overload common operators like the star, plus, minus, etc. Just like I showed, you can define new behaviors for these things, which is super powerful. And I'll show you, this is the only imaging application in this, but I'll give you an example, right, of what it would be like to do image conjunction the lazy way. So what I'm doing here is just creating a new class called LazyMask that just wraps nifty one image in nibabble. Doesn't do really anything else, except for this. We define these new methods and or, and these are going to override, they're going to overload the and the or operators. I'm just wrapping up. Actually, I promised I would ignore you when you walked in, so that. Okay. So I'll just show you what this does, and then I'll come back to the code. So here's us creating two new images. Normally you would create an nibabble image. Now we're calling this LazyMask thing, which inherits all of the properties of a nifty one image. But notice what we're doing here. We're doing this like image one and image two thing. Right? Like, that's kind of bizarre. If you try this on nibabble images, they won't like that very much. What is this doing? Well, let's see. So these are valid images now. I did this thing. I have this result thing. What does that look like? Let's quickly use nylearn to plot the result here. Take a little while. Okay, conjunction, right? One image, just a normal image. Second image, result is all the voxels that are defined in both of them. We can do the same thing. We have done the same thing, in fact, for disjunction. So let me go back and kind of really quickly walk through the code. What happens when you call that and operators, the first image gets, this is invoked, and now you can do whatever you want again. So what's happening is, first of all, it checks to make sure that the shapes of the two images are the same. If not, you can't do conjunction. And then it just calls a standard NumPy thing, right? So it just takes the data from each one, does a logical and returns that as a new image. So it saves you like 3 lines, but it's, in some ways, it's a much more powerful way to think about what you can do, right? You can very quickly, so with this you could do things like, you could very easily build up to things like, image 1 and image 2, or image 3, and image 4. And now imagine writing this out in like NumPy code. You would have this like construct that's like 700 characters long. And so you can build a very powerful syntax for operating over all kinds of objects in really elegant ways. And I actually think, I would argue this, there's no reason why you shouldn't actually have this kind of syntax for working with masks, right?
Exactly.
Yeah.
Part of nibabble.
Is it?
It should.
Oh, it should be, yeah, I think so. So someone, this could be a good project. Someone can actually extend nibabble to include some of this and open a PR, and then, I think.
Might be a social engineering project, though.
Yes. Or you could just create your own competitor that just wraps and see what people use, right? Okay. So
which operand's overloaded method does it use? Right, like if they were mixed classes, or if you like explicitly change the and on the image 1 but not on image 2.
If you explicitly change, well, they're the same. They have the same class. So
is that the same class?
It's the first one. So there's also an R-and operator. So you can specify. So what happens if it doesn't find, like if the first one doesn't know how to handle it, Python will automatically check the second one. And so you can have a separate method that says if I come second, and that's useful with some mathematical operations where it doesn't mean the same thing, right? They don't commute. Okay. All right, I probably should, decorators in some ways, they're one of the coolest things, but I kind of feel I should stop. So you can go and find the slides and work through it. Decorators also take a little while. If you haven't seen them before, they can take a while to actually understand. So I'll just stop here. If you have other cool stuff you like, then we should probably just create like a hackpad or something, and everyone can add their own little tricks for different languages. But I will stop there and let Jeremy actually have a go.